All right, so we're actually starting our unit on trigonometry today. This is module 6. So there are a couple skills that you need to know before you can move on and be successful with this unit. So one thing I want to review is when we see right triangles, what should come to mind is the Pythagorean theorem. And the Pythagorean theorem is, of course, a squared plus b squared equals c squared. Okay, and this is used for side lengths. And so the key with the Pythagorean theorem is you have to know, are you looking for a leg or are you missing a hypotenuse? So what I like to do is I like to label my sides. So the hypotenuse is always the longest side, and it's the one that's directly across from the right angle. So if I were to label this one, I know that this side is C, and it doesn't matter which one's A and which one's B, just know that your other two sides are called legs. Okay? Now there's two ways we can set up this problem. If we are missing the hypotenuse, such as this example here, we can use the simple formula of a squared plus b squared equals c squared, which we've done multiple times in this unit. If you are missing a leg, such as this problem here, you can set it up using the Pythagorean theorem, or I'm just going to set it up where I'm going to say c squared minus a squared is going to give me b squared, which is basically the same thing. You're just setting it up so you don't have to do the subtraction later. So that's step one, is to determine which formula you're going to use. Okay? Now step two, you're going to go ahead and, wow, I wasn't expecting that to happen. So, okay, so the first step obviously is to determine which formula you're going to use. Are you missing a hypotenuse? Then you'll use this formula here. If you're missing a leg, use the other formula. Okay, step two is you're just going to go ahead and plug the numbers in. So here I've labeled my legs and my hypotenuse. So this is going to be 6 squared plus 8 squared equals 6c squared. Well, 6 squared, you can just type this in your calculator, or you can do 36 plus 64, that's equal to 100. And then the very last step, and so for step 2 over here, I'm going to plug in 5 squared minus 4 squared. And again, it doesn't matter if it's A or B. Here, it would be B squared. So this is 25 minus 16 is equal to B squared. All right? And so 25 minus 16, I'll work it out over here. That's 1. That's 9. So this equals 9. Okay. Now the last step, step 3, this is my favorite step, is all you have to do is take the square root. So this would be the square root of 100 equals 10. So I can say that this side right here is 10. And I can check, because I know the hypotenuse always has to be the longest side. And so I can quickly check by saying, oh, okay, see, this side is 6, this side is 8, this side is 10, it's okay. And over here, the square root of 9 is step 3. The square root of 9 is 3. And so I can say that this side is 3, right here, the missing side. And I can look, I have 3, 4, and 5. So my hypotenuse is the longest side, so I've checked out. So there are 10 practice problems that you need to do for Pythagorean theorem. You want to go up to the front table, check to make sure it says Pythagorean theorem review, get those 10 problems, the first one's done for you, and go ahead and work out 1 through 10. When you're done, you want to pause the video. When you're done, come back and I'll show you how to do the next skill that you need to review. Okay, the second skill that we need to review is how to simplify a radical. And so these are all radicals. I know they're radicals because they have this thing right here, which we call the square root symbol, or radical. Okay? So to simplify radicals, there are some basic steps that you need to follow. There's approximately 3 of them. So the first thing you need to do is you need to list your factor pairs for 147. And so what I do is I just take my calculator out and I divide. And I start with 1, goes in 147. Then I say 147 divided by 2. Well, that's not going to happen. And then I say 147 divided by 3. That's 49. I'm circling this because 49 is a perfect square. So you have to know your perfect squares, okay? And they're listed on the worksheet that you're going to get. All the perfect squares are listed across the top, okay? Not all of them, but the first 20 of them or 21 of them are, okay? So then that's step 1. So step 1 is to make is to find my factor pairs. Step 2 is to circle perfect squares. Okay, now I'm going to make my factor tree. And so this is 3 times 49. I'm going to pull out, so this is step 3. I'm pulling out the square root of 49 because that's my perfect square. So 49 is 7 times 7. So the 7 goes in front, and I leave the rest behind. So I'm going to leave the square root of 3 behind. So the square root of 147 can be written as 7 square root of 3. Now you can check your answer by multiplying. 7 times 3 is 21, and 21 times 7 is 147. So it checks out. This is multiplying. So I have done this correctly. Okay, so you do a circle, multiply to see if you get the right answer. All right, let's do another example together. So step 1 is I'm going to list my factor pairs of 80. So I'm getting my calculator out. I start with 1. I divide 80 by 2, which is 40. 3 doesn't go in, but 4 goes in 20 times. Now 4 is a perfect square, but it's a small one. I want to hold out for a bigger perfect square, so I'm going to keep going. 5 goes in 16 times. That's a bigger perfect square. That one I can deal with. Okay. Plus I know that 5 is a prime number. So that's step 2, circle my perfect square. Step 3 is I'm going to make my factor tree. So it's 5 and 16. 16 is the one that's the perfect square. It's 4 times 4. So I'm going to pull out a 4, and I'm going to leave 5 behind. And then I can check to make sure that I did this correctly by multiplying 4 times 5 is 20. 20 times 4 is 80. And since these two numbers match, I've done it correctly, and we're good to go. Now this number can be a little intimidating. 294, you do it the same way. You start with my factor pairs. It might seem a little time consuming, but trust me, this is the quickest, easiest method. I'm going to divide by 2. So 294 divided by 2 is 40. 3 is not going to go in evenly. 4 goes in 20 times. Now 4 is a perfect square, but I'm going to hold out for something. I'm sorry, I'm doing the wrong. Let me start over. I was just repeating what I just did. We're going to start with 1, 294. 2 goes in 147 times. 3 goes in 98. I still don't see a perfect square. Okay. 4 doesn't work evenly. 5 doesn't work evenly. But 6 goes in 49 times. And 49 I know is a perfect square. Okay. So I'm going to rewrite this as 6 square root of 49 because that's my perfect square. So it comes out as 7 square root of 6. And then I can check my answer by doing 7 times 6, which is 42, and then 42 times 7, which is 294. And since I ended up where I started, I can check this out. All right, you're going to go ahead, and if you haven't grabbed it already, you want to practice the 10 problems that say simplifying radicals. Simplifying radicals, okay? These are some example problems. The notes are on the back. You need to get all 10 correct because this skill is something you need to be able to do to be successful in this unit. This is prior knowledge, okay? Now we're going to go pause the video, work those out, or you can just watch the notes on the next thing, which is rationalize the denominator. Believe it or not, this word says denominator up here. Okay, So to rationalize a denominator, you can get this done in about 5 steps, okay? So the first thing you need to do is we're going to look at 2 examples to start out. We're going to look at the example of the square root of 20 over the square root of 64, okay? And over here we're going to look at the square root of 10 over the square root of 8. So the first thing you want to look for is there a perfect square? So you're going to look for a perfect square first, okay? And ask yourself, is there a perfect square in the denominator? And if you know the square root of 64 is, the square root of 8 is not, okay? So we're going to work one that is, and this one is not, okay? So what you do if it is a perfect square is you just take the square root. So basically for you to have a fraction, you cannot have a radical symbol in the denominator. It's not mathematically okay. So we have to make sure we rewrite our fraction, keeping equivalence but not having a radical in the denominator. Okay, so what you do is you just simply take the square root of 64, which is 8. So now we've got the square root of 20 on top of 8. Okay, so far this is mathematically correct. However, you can then simplify. So this is step 1. Step 2 is to simplify the radical, which you just learned how to do, right? So we're going to simplify the square root of 20. So 1 times 20, 2 times 10, 3 doesn't go in, 4 times 5. Now this time I know that 4 is going to be my largest perfect square. So 4 and 5, 4 is going to come out as 2, and the square root of 5 is going to be left behind. So now I rewrite my fraction as 2 square root of 5 over 8. And my last step, step 3, is to simplify the fraction. And so the fraction I'm simplifying is right here, 2 and 8. You can divide both of them by 2. And so I get square root of 5, because 2 divided by 2 is 1. Divided by 8 divided by 2 is 4. So the final answer would be the square root of 5 over 4. Now, if you do not have a perfect square in the denominator, then what you have to do is multiply the top and the bottom by the square root of 8. So then what you end up with is the square root of 10 times the square root of 8, which is the square root of 80, because 10 times 8 is 80, but it stays in the radical. Now this is what's interesting. You might want to take your calculator out and take the square root of 8 times the square root of 8. And what you'll notice is that you get 8. Anytime you multiply 2 square roots together, it basically cancels itself out. So if I did, let me go to a different page here. If I did the square root of 2 times the square root of 2, that's just 2. The square root of 1,482 times the square root of 1,482 equals 1,482. They cancel each other out. All right, back to where we were. So now I've got this. Now I just follow the same steps that I followed down here. So step 2 is to simplify the radical. This time I'm simplifying the square root of 80. So the square root of 80 is, we just did this one. I think it's 240, 3 doesn't go in, 420, 516. So this is 5 times the square root of 16. It's the square root of 5 times the square root of 16. I'm going to pull out the 16 as a 4. The square root of 5 stays behind. And I put it over 8. Now I notice that I've got this fraction that I can simplify. I'm going to divide both by 4, and I'm finally left with the square root of 5 over 2. So my final answer is the square root of 5 over 2. go ahead and practice rationalizing the denominator. You need to watch the video